The first American aircraft carrier that appeared on Admiral Isoroku Yamamoto's intelligence reports in late 1943 seemed impossible according to every calculation about shipbuilding capacity and industrial resources. USS Essex, launched just 18 months after Pearl Harbor, represented American naval construction capabilities that challenged fundamental Japanese assumptions about democratic industrial organization and wartime production limits. How can they build carriers faster than we can construct destroyers? Yamamoto asked his staff at Combined Fleet Headquarters, studying reconnaissance photographs that showed multiple American flat tops under simultaneous construction at shipyards across the United States. Our intelligence estimated American shipbuilding at perhaps 6 carriers by 1945. These reports suggest they will have completed 50. These were experienced Japanese naval planners who understood maritime construction through decades of careful resource management and systematic industrial organization. They had calculated American shipbuilding capacity, analyzed steel production limits, and developed mathematical models proving that democratic societies could never achieve the disciplined production necessary for massive naval expansion. They had no way of knowing they were witnessing the greatest naval construction program in human history, or that American shipyards would fundamentally overwhelm Japanese naval capabilities through industrial abundance that rendered tactical excellence strategically irrelevant in Pacific warfare. Admiral Isoroku Yamamoto stood on the bridge of flagship Yamato in Truk Lagoon during February 1943, reviewing Japanese naval capabilities that seemed adequate to maintain Pacific dominance despite increasing American military activity. As architect of the Pearl Harbor attack and Japan's most experienced naval strategist, Yamamoto embodied confidence in Japanese technological superiority and strategic planning that had achieved remarkable early war successes. The Imperial Japanese Navy that Yamamoto commanded possessed 10 aircraft carriers, including the world's largest and most advanced flat tops that had dominated Pacific warfare since December 1941. Japanese carriers featured superior aircraft, experienced pilots, and tactical innovations that had outclassed every Allied opponent through systematic application of naval aviation doctrine. Japanese shipbuilding capacity reflected decades of careful planning and resource allocation that had created modern naval vessels through systematic industrial organization and technical excellence. Japanese shipyards produced carriers, battleships, and destroyers using precision methods that emphasized quality over quantity while maintaining technological advantages through superior engineering. Intelligence analysis of American naval construction suggested democratic shipbuilding remained limited by resource constraints, labor disputes, and industrial inefficiencies that prevented rapid naval expansion. Japanese planners calculated that American carrier construction would require years to match Japanese capabilities while maintaining acceptable quality standards. The strategic doctrine that guided Japanese naval operations assumed carrier superiority would maintain Pacific dominance through tactical excellence and pilot training that exceeded American capabilities. Japanese aviation had demonstrated consistent victory over Allied naval forces through superior aircraft performance and aircrew competence. Economic calculations performed by Japanese naval planners revealed American industrial capacity divided between civilian production and military requirements, suggesting resource limitations that prevented total naval mobilization. Steel allocation, shipyard capacity, and skilled labor appeared insufficient for massive carrier construction programs. Cultural assumptions about American society suggested democratic inefficiency and individualistic attitudes that prevented systematic industrial organization necessary for major shipbuilding programs. Japanese propaganda characterized Americans as undisciplined consumers who lacked collective dedication required for sustained military production. The technological advantages that Japanese carriers possessed included advanced aircraft catapults, superior damage control systems, and innovative flight deck designs that reflected years of naval aviation development. Japanese engineering had solved technical challenges that created operational capabilities exceeding American naval technology. Combat experience from early Pacific operations validated Japanese assumptions about carrier warfare effectiveness and tactical superiority over Allied naval forces. Japanese aviation had achieved consistent victory through pilot skill and aircraft performance that seemed impossible for American forces to match. Strategic planning for prolonged Pacific warfare assumed Japanese naval advantages would enable defensive victory through tactical excellence and technological superiority that would overcome American numerical advantages. Quality appeared more decisive than quantity in naval aviation operations. International naval analysis recognized Japanese achievements in carrier design and naval aviation that had established clear technological leadership in Pacific maritime warfare. Professional assessment confirmed Japanese superiority in most naval aviation categories. Resource management within Japanese military industry prioritized naval construction quality over production quantity, reflecting confidence that superior vessels would achieve victory through tactical advantages rather than numerical superiority. The rising sun's confidence appeared mathematically justified, and Japanese naval commands planned continued operations based on assumptions about technological and tactical advantages that would soon face unprecedented challenges from American industrial capabilities exceeding any calculation of democratic production possibility. Henry Kaiser walked through the Richmond Shipyard No. 4 in California, observing construction techniques that were revolutionizing aircraft carrier production through mass manufacturing methods adapted from Liberty ship construction. The industrialist who had transformed merchant shipbuilding was applying the same systematic approaches to naval vessel construction that would soon overwhelm Japanese carrier capabilities through unprecedented production rates. The Essex-class aircraft carrier program that American shipyards undertook represented the largest naval construction effort in maritime history, utilizing assembly line techniques and prefabrication methods that enabled carrier completion in 18 months, rather than the traditional 3-year construction periods that Japanese shipyards required for comparable vessels. Workforce mobilization supporting American carrier construction included unprecedented numbers of women entering shipbuilding trades while maintaining industrial training programs that created skilled workers adequate for complex naval vessel assembly. Democratic education systems produced human resources through systematic instruction and competitive development. The technological standardization that American carrier design achieved eliminated custom engineering and individual craftsmanship that characterized Japanese shipbuilding, enabling mass production through interchangeable components and systematic assembly procedures. Standardization created efficiency advantages that exceeded traditional naval construction methods. Newport News Shipbuilding demonstrated American capability to construct multiple carriers simultaneously while maintaining quality standards adequate for combat operations. The Virginia facility operated continuous production schedules that delivered completed carriers monthly during peak construction periods. Supply chain coordination across American naval construction included steel delivery from multiple sources, specialized components from hundreds of subcontractors, and systematic materials management that maintained construction schedules despite continental distances. Logistical organization exceeded Japanese capabilities through systematic resource allocation. Quality control procedures ensured carrier seaworthiness and combat capability through systematic testing and continuous inspection that validated American mass production methods. Naval vessels achieved reliability standards through scientific approaches to manufacturing quality rather than individual craftsmanship attention. Innovation acceleration continued throughout carrier construction as American engineers improved design specifications, manufacturing techniques, and operational systems while maintaining delivery schedules. Competitive pressure encouraged technological advancement that exceeded traditional shipbuilding development methods. The economic efficiency that American carrier production achieved included cost reduction through volume manufacturing while maintaining performance standards that met naval combat requirements. Industrial competition created cost advantages through systematic optimization and efficient resource utilization. International cooperation through Lend-Lease programs demonstrated American confidence in production capacity that exceeded domestic requirements while supporting Allied naval capabilities. Surplus construction capacity enabled generous assistance that strengthened coalition warfare effectiveness. Training programs for naval personnel paralleled carrier construction through systematic instruction that prepared crews for new vessel operations. American naval education created human resources adequate for expanded fleet operations while maintaining professional competence standards. Strategic planning that anticipated massive carrier deployment included operational doctrine development, tactical innovation, and logistical support systems that would maximize fleet effectiveness. American naval strategy incorporated production advantages into comprehensive campaign planning. The maintenance infrastructure supporting carrier operations included repair facilities, spare parts production, and technical services that enabled sustained combat operations. American logistics created systematic support that maintained operational readiness throughout extended campaigns. Research and development programs continued improving carrier design and operational capability through competitive innovation that enhanced naval aviation effectiveness. Scientific advancement accelerated technological development that exceeded traditional naval engineering methods. The shipyard revolution was creating naval capabilities that would soon challenge Japanese assumptions about carrier warfare through systematic production rather than individual vessel excellence alone. December 1943. Japanese naval intelligence documented American aircraft carrier construction that defied every assumption about shipbuilding capacity and industrial organization. Intelligence reports from multiple sources confirmed that American shipyards were completing fleet carriers at rates exceeding one vessel monthly while maintaining construction quality adequate for combat operations. Commander Minoru Genda studied reconnaissance photographs showing simultaneous carrier construction at Norfolk, Newport News, Brooklyn, and Four River shipyards that represented industrial capabilities beyond Japanese comprehension. American shipbuilding had achieved production rates that violated traditional assumptions about naval construction complexity and resource requirements. The statistical analysis that Japanese naval planners performed revealed American carrier completion schedules that exceeded Japanese total shipbuilding capacity across all vessel types. Enemy construction rates indicated industrial mobilization that challenged fundamental understanding of democratic society organization and wartime resource allocation. Economic calculations demonstrated American naval expenditure that exceeded Japanese military budgets while maintaining civilian production and global military commitments simultaneously. Democratic industrial capacity had achieved systematic abundance that contradicted Japanese assumptions about wartime economic limitations. Intelligence gathering through multiple sources confirmed American carrier construction that included Essex-class vessels exceeding 24 units, with additional Independence-class light carriers approaching 30 completions. Enemy naval expansion represented mathematical impossibility, according to Japanese industrial knowledge and shipbuilding experience. Technical assessment of captured American naval equipment indicated manufacturing quality that equaled Japanese precision, while being produced in quantities that Japanese industry could never approach. Mass production had achieved reliability through systematic methods rather than individual craftsmanship attention. Strategic implications of American naval construction included carrier capabilities that would overwhelm Japanese fleet strength through numerical superiority rather than requiring technological advantages or tactical excellence. Quantitative factors had become decisive in naval warfare mathematics. The psychological impact on Japanese naval officers included recognition that enemy industrial capabilities exceeded tactical responses available through existing fleet strength and strategic planning. American abundance had eliminated traditional naval limitations while creating operational possibilities that Japanese planning had never contemplated. Supply chain analysis revealed American naval construction coordinated across continental distances with material flows that exceeded Japanese logistical capabilities. Enemy industrial organization demonstrated systematic efficiency that challenged Japanese assumptions about democratic society, coordination, and resource management. Workforce development supporting American shipbuilding included personnel training that created skilled workers through systematic instruction rather than traditional apprenticeship methods. Democratic education had produced human resources adequate for unprecedented naval construction while maintaining quality standards. Innovation integration throughout carrier construction demonstrated American ability to improve design specifications while maintaining production schedules through competitive development rather than traditional engineering approaches. Technological advancement had accelerated through systematic research and industrial application. International cooperation through American naval construction included technology sharing and resource coordination that enhanced Allied capabilities while demonstrating production capacity beyond domestic requirements. Democratic cooperation had multiplied individual national advantages through systematic alliance coordination. The maintenance challenges that massive carrier deployment would require included logistical support systems that exceeded Japanese understanding of fleet operations and resource allocation. American naval planning had incorporated unprecedented fleet sizes into comprehensive operational doctrine. Quality assurance achievements in carrier production demonstrated American manufacturing capabilities that maintained naval combat standards while enabling systematic construction that traditional shipbuilding methods could never achieve through individual vessel attention. The mathematical impossibility had become operational reality that would soon challenge Japanese naval strategy through American industrial capabilities that exceeded any traditional calculation of shipbuilding capacity and democratic resource mobilization. June 19, 1944. The Battle of the Philippine Sea revealed the devastating effectiveness of American naval construction as Task Force 58 deployed 15 aircraft carriers against Japanese Mobile fleet forces that had been systematically weakened by carrier losses and irreplaceable pilot casualties. Admiral Raymond Spruance commanded naval aviation capabilities that exceeded Japanese response possibilities through systematic abundance. The carrier deployment that American forces achieved included 9 Essex-class fleet carriers and 6 Independence-class light carriers, operating with coordination that demonstrated industrial advantages translated into tactical superiority. Japanese forces faced enemy naval aviation that exceeded their total remaining carrier capability. Japanese pilot losses during the engagement included experienced aircrew whose replacement required years of training that Japan could not provide under wartime conditions. American pilot preparation continued through systematic instruction that created adequate human resources for expanded carrier operations. The technological advantages that American carrier aviation demonstrated included superior aircraft, advanced radar systems, and systematic maintenance that enabled operational readiness exceeding Japanese capabilities. Industrial quality had created tactical advantages through competitive development and systematic resource allocation. Combat results from the Philippine Sea engagement included Japanese aircraft losses exceeding 600 planes, while American casualties remained minimal despite enemy tactical innovation and pilot dedication. Numerical superiority had overwhelmed Japanese tactical excellence through systematic abundance. Strategic implications of American victory included Japanese recognition that carrier warfare mathematics had shifted decisively in favor of enemy industrial capabilities that could not be matched through tactical improvement or resource reallocation. Quality advantages had become irrelevant against systematic abundance. The psychological impact on surviving Japanese naval officers included understanding that American carrier construction had eliminated strategic balance while creating operational situations where Japanese fleet effectiveness could not influence tactical outcomes. Industrial superiority had rendered traditional naval planning obsolete. Intelligence analysis by Japanese commands revealed American naval capabilities that included construction rates maintaining carrier strength despite combat losses, while expanding total fleet size beyond Japanese response possibilities. Enemy industrial capacity had achieved sustained superiority through competitive production methods. Economic calculations indicated American naval construction costs that decreased through volume production, while maintaining technological advantages that exceeded Japanese development capabilities. Industrial efficiency had created cost advantages through systematic manufacturing optimization. International cooperation supporting American operations included Allied naval coordination that enhanced collective effectiveness while demonstrating American production capacity that exceeded coalition requirements. Democratic alliance systems had multiplied individual advantages through systematic cooperation. The maintenance infrastructure that supported American carrier operations included repair capabilities, spare parts availability, and technical services that maintained fleet readiness under combat conditions. Systematic logistics had created operational advantages that exceeded Japanese resource allocation possibilities. Training programs that prepared American naval personnel included systematic instruction that created competent crews for expanded fleet operations, while maintaining professional standards adequate for complex carrier operations. Educational advantages had produced human resources through competitive academic development. Innovation acceleration in American naval aviation included continuous improvement in aircraft performance, carrier operations, and tactical doctrine that exceeded traditional development methods. Competitive pressure had encouraged advancement that maintained technological leadership. Medical services supporting carrier operations included advanced facilities and systematic procedures that enhanced personnel survival and operational effectiveness. Healthcare advantages had improved human resource utilization while reducing casualties. The Great Marianas Turkey Shoot had demonstrated American naval construction effectiveness through combat results that validated industrial strategies while proving that systematic abundance could achieve decisive victory over traditional tactical excellence and individual vessel quality. August 15th, 1945. As Emperor Hirohito announced Japan's surrender, American naval forces dominated Pacific waters with 99 aircraft carriers of various classes that represented the most massive naval construction achievement in maritime history. The industrial democracy that had been dismissed as inefficient had fundamentally transformed naval warfare through systematic abundance rather than individual vessel excellence. The final accounting of American carrier construction revealed production totals that had exceeded every Japanese calculation about democratic industrial capacity. Essex-class fleet carriers numbered 24 completed vessels. Independence-class light carriers reached 9 units, while escort carriers exceeded 50 completions through mass production techniques. Admiral Yamamoto's prediction about American naval weakness had proven catastrophically incorrect, as democratic industrial organization achieved construction rates that overwhelmed Japanese tactical advantages through systematic abundance. American shipyards had delivered carriers faster than Japanese forces could sink them while maintaining technological superiority. The strategic validation that American naval construction provided confirmed industrial mobilization as decisive factor in modern naval warfare, while demonstrating democratic advantages in resource allocation, technological development, and systematic production that exceeded authoritarian alternatives through competitive innovation. International cooperation through American carrier operations included vessel transfers to allied nations that enhanced collective naval capabilities while demonstrating production capacity beyond domestic requirements. Democratic generosity had strengthened alliance systems through systematic technology sharing and resource coordination. Economic efficiency that carrier construction achieved included cost reduction through volume production, while maintaining combat effectiveness that exceeded traditional shipbuilding methods. Competitive capitalism had proven superior to command economy organization for systematic naval development and industrial mobilization. The educational systems that produced American shipyard personnel created human capital advantages through competitive academic development that exceeded traditional naval construction methods. Democratic education had produced technological capabilities through systematic knowledge development and competitive instruction. Technological legacy of American carrier construction influenced post-war naval development through innovations that continued shaping maritime warfare and international naval competition. Scientific advancement had created lasting advantages through systematic research and competitive development. Quality control achievements in carrier production demonstrated American manufacturing capabilities that maintained naval combat standards while enabling systematic construction that traditional methods could never achieve. Scientific manufacturing had produced excellence through systematic quality assurance. The workforce development that enabled carrier success demonstrated democratic society's ability to mobilize human resources through opportunity and education rather than coercion. Competitive systems had produced capabilities that exceeded authoritarian alternatives through systematic human development. Strategic implications of American naval dominance included post-war maritime leadership that would influence global naval balance through technological advantages established during wartime construction. Democratic naval power had achieved systematic superiority that would shape international relationships. Innovation acceleration that carrier development represented established American shipbuilding as global leader in naval construction through competitive research and systematic development that exceeded traditional maritime industry methods. Supply chain resilience that carrier construction demonstrated included resource coordination and logistical management that maintained production schedules despite global commitments and material competition. Systematic organization had achieved efficiency that exceeded traditional industrial methods. The Pacific had become an American lake through naval construction that proved democratic societies could achieve systematic advantages over traditional military excellence through industrial cooperation, competitive innovation, and systematic resource mobilization that authoritarian systems could never match through coercive control or ideological motivation alone. If this incredible story of how American naval construction overwhelmed Japanese carrier capabilities through democratic industrial supremacy amazed you, make sure to subscribe to our channel for more untold tales of industrial victory.